Hey everyone, continuing on our recording journey, let's talk a little bit more specific about microphones. Today's lesson will be really helpful if you want to get sort of more comfortable with like thinking about recording and what are the different types of microphones, when are you going to want to use them, what types of microphones are good for what types of instruments or voices. So we're really going to dive into the fundamentals of that today, talk about the key terminology that distinguishes different types of microphones, and talk about some use cases. So today's topic is Introduction to Microphones. What is a microphone, right? So we think back to our last discussion, we think about a microphone as a transducer, right? That is a device that changes information from one form to another. So we're taking sound pressure changes and we're converting them to electricity to either be amplified in a live performance setting or to be recorded in a recording. So quick review on how microphones work, right? Sound information exists as patterns of air pressure. The microphone changes this information into patterns of electric current. The recording engineer is interested in the accuracy of this information as a concept known as fidelity, right? We could go on to, to Amazon right now and buy a USB mic for $20 or $30, right? Which is really impressive. Why would somebody then spend $3,000 on a mic or $10,000 on a mic? There's certain vacuum tube microphones, Telefunken and other companies that make their $10,000 just for that microphone. Again, the answer is about fidelity. How accurately is that microphone capturing the sound? Right? All microphones will make changes to the sound, right? We all know this probably the first time we heard our recorded voice and it sounded different from how we perceive ourselves, right? I mean, part of that is how we're hearing our own voice through the reverberations in our body, but also microphones color the sound of anything they record. So more expensive microphones are known for their ability to either just very nicely capture without coloring or coloring in a very complementary way, right? There's certain microphones people like to record voices because they increase the frequencies that sound good on certain types of voice types. Or there's certain microphones that people like on guitar amplifiers because they maybe increase the certain frequencies that are good for guitar amplifiers. So the variations in microphones occur either because they're just one, better at recording sounds and don't color the sounds, or if they do color the sounds, they do it in such a positive way that they benefit those sounds rather than sort of detract from it. So microphone classification. Let's take a look at the broad types of microphones. Understanding how different microphone types function and what their strengths and weaknesses are allows us to select the right tool for the right job. So we can often think about cooking. You're going to hear a lot of cooking metaphors in this class. So we can think about a chef, right? I'm a huge fan of the show, Top Chef. And, you know, when somebody goes home, they say, pack your knives and go. So a chef always has different knives for different applications, right? You're going to want to use a paring knife for certain things, and you're going to want to have like a serrated knife for bread or tomatoes, and you want to have a large knife for meat, right? There's lots of different knives that you need. Similarly, if you are going to be, starting a recording studio or even just a home studio, you're going to need different microphones for different situations. Some of them will be good for loud signals. Some of them are good for quiet signals. Some of them are great for capturing a large ensemble because they're picking up sound in all directions, whereas others would be good for rejecting noise, only capturing the singer while not getting the sound of their bandmates behind them. So there are four major types of sound conversion systems which are used to classify microphones: dynamic, condenser, ribbon, and contact or piezo. If there's any guitar players or violin players in the group, you're used to using on an acoustic instrument a piezo pickup, which captures the sound directly of vibrations. We'll talk about that in a little bit more detail in just a moment. First, let's talk about dynamic microphones. So dynamic mics have the benefit of being tough and relatively inexpensive. They don't require an external power source. So there's been a lot of talk recently about inflation, but there seems to be one microphone that is immune to inflation, which is the SM57 microphone, which has been $99 for my entire music career, going back to the early 2000s. It's a really powerful mic and it's really inexpensive. Its sort of sister microphone is the SM58, which is probably the microphone that's being used by this hardcore band. It's a very similar capsule, but it has a sort of filter inside, so it's really good for vocals. It won't overemphasize breath noise and that sort of stuff. So these microphones, the sort of running joke amongst audio engineers is that they're indestructible. You can drop them off of a building and they'll still work. They're also really good. So they're really good at capturing sound, and that's why they're used so frequently. So some characteristics of dynamic microphones: they can withstand loud volumes without damage to the microphone or sound distortion. They can withstand extreme temperatures. So they're ideal for outdoor usage. So if you're going to be performing with your students outdoors, dynamic microphones will be appropriate for that situation. A dynamic microphone usually has less upper frequency than a condenser microphone. They'd be great for recording something like trombone or tuba. Maybe not so great for recording violin, right? So that's the good thing about dynamic microphones. They're really durable. They do good with loud sounds, percussion, brass, voice, pop voice. They're good, rejecting sound from not right in front of them. So this is why they're the archetypical live sound microphone. Dynamic mics in the studio. So in the studio, they have some applications as well. These are not just for live performance. In the studio, they're used to record guitar cabinets. Here we can see this Shure SM57 on a guitar amp, pointed right at the speaker. The Electro Voice RE20. This is a really great, if you go to a radio station, you're doing an interview on the radio, you'll see this voice a lot, this Electro Voice RE20 a lot. Here's a Sennheiser MD421 used a lot for recording toms. And here is another, you can't see because of the video, but this is the same mic here. This is the SM57, also really popular mic for snare drum. So let's talk about another type of microphone, which is a condenser. Right? If we think back to the syllabus, this is the type of microphone that I asked you to invest in, or that you're going to be borrowing from the library. This is the mainstay of the professional recording studio. So if you're going to have just one microphone, a condenser microphone is it, particularly for recording. If you're more of a live vocalist, you might want to have just a dynamic microphone that you really love that you can take to the venue with you. But if you're going to be doing recording, a condenser microphone is probably the way to go if you're just going to have one microphone. Their weakness lies in their high cost compared to dynamic models. Their reliance on 48-volt phantom power. So these microphones have circuitry that needs a little bit of power. So you're going to be using your microphone cable not just to pass signal from the mic to the audio interface, but you're also going to be using your cable to pass a little bit of voltage, 48 volts, to the microphone, so the internal circuitry has enough power to work. Sensitivity of internal components to condensation makes them less ideal for outdoor use. Remember back to our microphone discussion, we had that very thin plate of like gold in there, right? Or aluminum or some sort of metal in there. So it's not going to be really good if there's humidity. So you're not going to want to really use these microphones outside. They're really studio microphones. They're great for recording choir instruments and can pick up sounds from greater distance than dynamic microphones. So let's say you're a choir director, right? If you take one SM57 dynamic microphone and stick it 6 feet in front of your choir, it might pick up the few students that are standing right there. It's not going to be good for picking up your whole choir. That's something where condenser microphones will come in. Especially an omnidirectional or figure-8 microphone that can pick up sounds in lots of different directions. And we'll look in that in a little bit more detail in just a moment. Condenser microphones. Here's some common microphones. The Audio-Technica 4040. It's a really great microphone. It's actually the microphone that I'm recording this lecture on. I have a nice little wind filter on it, but you can see it right there. It's like a just great overall microphone. It's good for vocals. It's good for acoustic guitar. It's good. You could use it on a guitar amplifier in a pinch if you needed to. Lots of common recordings. I've used it on strings. It's a really nice overall microphone. It's not too expensive. It's around $400. So it's a good sort of microphone to have. It also has its sort of little cousin, the AT2020. Now, that's about $100, and it's been used on some really big recordings. Billie Eilish, when she was first getting started, used that vocal recording on her first album, the AT2020. So with good hands and good ears, you can make that $100 microphone sound great. The Neumann U87, this is sort of the envy of all microphones. It's about $3,000, I believe, as of time of recording. It's made in Germany. It's one of the, classic condenser microphones that you'll see in professional recording studios. It's great for vocals. It's known for its warm sound. And there's other types of microphones that are condenser microphones that are a bit smaller. Here we have the Rode M5 stereo pair. So these are small diaphragm condensers. You'll often see them used as pairs. They're great for stereo recording, right? So we're going to use two of those to sort of map to our two speakers of our speaker system or our two headphones, so we get a more realistic recording that sort of sounds like how we hear music, right? We hear music with both ears. So by using two condenser microphones, we can get a great stereo recording. There's a third type of microphone that's a little bit less frequent nowadays, but is still really revered amongst audio engineers, and this is the ribbon microphones. So ribbon microphones feature an extremely thin strip of metal, mostly aluminum, suspended in a strong magnetic field. The ribbon acts as both the diaphragm and the transducer element itself, providing the same kind of sensitivity and transient response you'd expect from a condenser, but with a different sonic characteristic, a little bit smoother, warmer sonic characteristic than a condenser, which sometimes can be overly emphasized the high frequencies. So here is the Royer R122. We have one of these mics in the Center for Music Technology. It's a really nice microphone for capturing things like acoustic guitar, for capturing guitar amplifier or piano. If you put two of these on a piano, it sounds beautiful. Probably a lot of the classic jazz recordings, Rudy Van Gelder, Blue Note, these were probably used on piano. They're really beautiful microphones. They're a bit older than the condenser microphones, which were not available to the 1970s. So these go back to the 1920s. Like dynamic microphones are passive. They don't need any external power source. Ribbon microphones have a lower signal output than condenser microphones, thus require a preamplifier with sufficient gain. So if you have something like a Focusrite interface, you might need to turn the gain on that ribbon microphone all the way up, and even that might not be enough. So usually with these type of microphones, you need some sort of specialized preamplifier to really get the best out of them. One of the greatest attributes of ribbon microphones is they're highly detailed without being oversensitive to high frequencies. So they're really great when you want detail without too much high end. And finally, contact microphones. A contact microphone is known as a piezo microphone, senses vibrations through solid objects. So as a string player, you might be on the stage and you're playing and you have a microphone on you, and it's still really hard to hear you in the audience, and the engineer has to keep pushing that microphone, the traditional microphone gain up until you get feedback, and nobody wants feedback. So the beautiful thing about contact microphones for string players, that's both strings and guitars and that all stringed instruments, is that they pick up the sound right from the bridge of the instrument, right from the sound source. So even if that violin player is on stage with a drummer, they're not going to get feedback. They're really nice pickups for that. If you've purchased an acoustic electric guitar at any time, it has one of these built in. They could also be added on later, as you see in this picture right here with that microphone on the bridge. And here's your standard 1/4-inch cable connector right there. So unlike dynamic and condenser microphones, contact microphones are almost completely insensitive to air vibrations, transducing only structure-borne sound. Feel free to take a little break, grab a sip of coffee, a little water. We've covered a lot of information. We have a few more things to go over. Polar patterns. So I'm going to link this video below. What is a polar pattern? This is a really great overview of what the different polar patterns are. There are some microphones that have multiple polar patterns, or there's some microphones that only have one polar pattern. So it's really important when you're purchasing a microphone to see what type of polar pattern it has. Let's dive into that a little bit. Okay, I'm saying this word polar pattern. Dr. Arne, what does that mean? What do you mean when you say polar pattern, right? These are mics that are designed for different recording scenarios, right? So let's give scenario number one. Let's look at our omnidirectional up here. Let's say you're in a band and you just want to capture a rehearsal. You could stick an omnidirectional in the middle of the room and it will pick up sound from all sides, right? It's really great for that. So there's some examples of like folk recordings that are done just on a single omnidirectional microphone. How far you place the player close to far away from the microphone will determine how loud they are. So you can really do your mixing just by where you're sitting in the room. So they're really great in capturing sound. They're also used a lot in classical music recording because they're not just capture the sound of the ensemble, but the sound of the hall, right? So if you're recording in a nice acoustic space like a church or a auditorium where you want to capture both the sound of the ensemble and the hall, an omnidirectional microphone might be good for that. Bidirectional microphones. Many ribbon microphones are bidirectional, which means they pick up sound from the front and the back. You can imagine a vocal duet where you have two singers and they each stand one side of the microphone. You have one singer over here, one singer over here. They're both singing. And then on the side of the microphone over here, you have your guitarist and your bass player. They're rejected from that microphone. The microphone is not sensitive to sound from the sides, just the front and the back. Can be really great if you're using combination. You could sort of put two of these off to the side of one another, and now you have a stereo omnidirectional setup. If you're a little bit more advanced, wanted to check out something that's called a Bloomline pair, that's a really great way of capturing ensembles using two bidirectional microphones. Cardioid, this is your most common type of microphone. All of your dynamic microphones tend to be cardioid. What they're really good at is you put your singer or your instrument right here, and it rejects some sound from over here, and it really rejects sound from back there. So it's really good at using recording or live amplification because it's sensitive just to sound in the front, not sound from the side or not sound from the back. Supercardioid is a little bit different. Again, it's good for side rejection, right? It's rejecting sound at the side. It captures a little bit of side sound in the back though. Hypercardioid is a variation on that. And ultracardioid really has a narrow polar pattern. It's even rejecting sound from over here. It's just receiving sound from over there. A little bit more rare, but it could be really useful, in news recording, like live field recording, where you just want to get the speaker that's right in front of you, and you don't want to get any of the sound from the street. Yeah. So how to read a polar pattern. Think of the 360 field surrounding the microphone. The 0 is the front of the microphone, right? So right here, and you can think about the scale of how large this sort of blob, I guess it is, for lack of a better word, is how sensitive it is to sound. So the more narrow, the more sound it rejects. The wider, the more sound it accepts. So that has to do with amplitude and sort of physical location. We also want to think about frequency response. What frequencies can each microphone capture? So frequency response is the range of frequencies an audio device will detect at a given level. So we can see here our dynamic versus our condenser. So let's read these, right? Let me help you break this down. So we see here, they both kind of have a cutoff below 200, right? If we look at here's 200, a little bit smoother slope here versus a more drastic slope here. So again, this is why the reason we don't really use this type of microphone on like an upright bass or on a kick drum. It's not really good at getting those really low sounds. This is a nice smoother roll off. And look at this, between 200 and about 5K, it's flat. It's not really doing any coloration at all. Here, if we look at the same thing between 200 and 5, you'll see it's much more of a curved line, right? It increases sounds here. There's a little bit of a dip right here, right? So these can be positive or negative depending on what you're trying to record, but it's good to be aware of what the microphone is doing. And then we kind of have a little boost around the 6K. We also have a boost here. Again, much smoother curve versus this is sort of a little bit more angular, right? And then we have a very steep drop off at 20,000 versus just a little bit, maybe a few decibels or drop off here around 20,000. So again, this is going to work great on a cymbal. It's going to work great on a violin, anything that has a lot of high frequency content versus this, it's really going to cut off. So whereas it might be good for a voice or a guitar, for a piccolo or something really high, the SM57 might not be your choice. So each of the above microphones have a present peak, right? We looked at that. So think back to your Fletcher-Munson curve, right? So the distance and proximity effect. If you've ever attended a punk music concert or hardcore concert, you'll often see a singer holding a microphone like this. And there's actually a physical acoustic reason they're doing that. The proximity effect increases the bass of the voice, right? So if you want those really growly, hardcore vocals, by putting the mic so close to your mouth, you're increasing the ability of that microphone to pick up low frequencies. So if we have 2 feet from sound source, a dip. We have 2 inches from sound source, it decreases. So good thing to think about, a good rule of thumb in the studio. If you want a clear vocal recording, I always say use your thumb to your pinky, stretch them out. That's the distance your singer should be from their microphone, right? If they're too on top of the microphone, like their lips are actually touching it, it's gonna be a lot of bass, and it's gonna be hard to get that out in audio and your editing. So for any kind of vocal performance where you want a natural sound, make sure that the singer is about 6 to 7 inches back from the microphone. There's some text here about the proximity effect, right? So anytime you're closer, like about 2 inches from the mic, you're going to get those more bass frequencies. Another key microphone term is sensitivity. Is like how much signal or output voltage is produced for a given loudness at a single source. So if you're looking at a microphone, you get that PDF online of the specifications, or if you just purchase it, it'll usually come with some sort of booklet. We'll have all these sort of technical details. A lot of microphones will have a pad on the back. So if you're recording overheads on a drum, you can shave 10 decibels right off the microphone to allow you to record without clipping. Signal to noise ratio. This is going to be really important in recording. In terms of the microphone's physicality, but also just as a good thing, a good general rule, is you want to capture as much signal and as little noise, and setting your gain knob to the proper setting will help with that. When you get to your recording projects, I will probably give you some feedback. Hey, you're probably pushing your mic too high, or more common, I see students being a little bit too conservative with that gain, not getting enough signal. The problem is that once you make that signal louder, you're also going to have some louder noise. So signal to noise ratio is really important. Feel free to pause this slide, take some notes. And impedance. So impedance is the measurement of resistance. Here we're getting a little bit into, if you ever have any family that are electricians or people who have studied electrical engineering, this is more of an electrical term. Impedance is the amount of resistance, uses Z as the sort of unit of measurement. Microphone output, while low Z, while pickups of electric guitar cables are high Z. The microphone output impedance must match or bridge the impedance load of a mic preamp. Don't have to worry about this too much, but it is a good term to see. You will see that high Z, low Z. So just remember this, maybe pause the slide, take some notes there, right? Mics are low Z, 1/4 inch guitars, high Z. Just has to do with how these electrical components are functioning. Definitely feel free to do a little bit deeper dive if this is something you're interested in. So there's a discussion activity. You'll see this below in D2L. Imagine that your program has just received a $2,000 grant from Music Technology specifically for upgrading your microphone locker. What types of microphones do you plan on purchasing for students? Try to include at least 3 types of microphones in your discussion reflection. Describe how you'd plan on using them, right? So if you're mainly going to be doing live sound things, maybe you're going to want to focus more on dynamic microphones. If you're going to be doing some recording, I would definitely recommend having at least one large diaphragm, maybe some small diaphragms too for stereo recording. So think about what your needs are. Go ahead and research some of the microphones I mentioned in this presentation. Take a look. There's some really great videos by Sweetwater as well on microphone types, and start to think about what would work best for you and your program. Excellent. Hope you enjoyed this presentation and look forward to seeing you in the next one. As always, let me know if you have any questions on this presentation via email or reach out to your peers in the peer forum. Thanks, guys.